Okay, so this is how I solve the merry-go-round question. So pretty much for the final answer is 355.72223953.642 joules. And this is how I solve it. So pretty much it's the merry-go-round. It doesn't give us any complex equations or masses or anything specific. So pretty much what we can assume is that it's just a cylinder. That is a terrible cylinder with a point, and then this is the rotation axis right there. Again, that's not straight, and that's okay. So pretty much I like to start by writing my givens, and that's just that. And the first thing we need to do is we need to find the moment of inertia, and that's related to this entire thing. And then we need to find the mass of the disk, meaning like the rotating mass or the rotating disk at the bottom. So pretty much to find the mass of the disk, it's going to be m is equal to Fg, force of gravity, all over gravity. So it gives us 8.59 newtons there. So it's going to be 800, did I say 8.59? I meant 859 newtons all over 9.8. That's gravity right there. And then that pretty much gives us the mass. It's going to be 87.653 kilograms. And I'd like to say something real quickly, and that is pretty much, so the rounding stuff, the final answer I gave you like a couple of seconds ago, that is pretty much the final answer. No rounding has been done at all. In this, as I work through the problem, I'm going to give you unrounded decimal answers, but I'm not going to give you the entire decimal. So if you're working this in the calculator, you just want to start using the arrow button and the enter, because you don't want to be like abbreviating this down, because I know that this probably goes on for far longer. And the next thing, like I said before, we need to find the moment of inertia. So pretty much the moment of inertia is going to be calculated by I is equal to 1/2 mr squared. And then that pretty much, if we sub in the numbers we have 1/2 times by the mass, which is 87.653, and then times by the radius, which is 1.22 squared. And then that should give us 65.23, oh, that's not 2. 65.2314 kilograms meters squared. And we're going to hold on to that number for now. If you see it boxed, it's pretty much hold on to that number for now. And then next we need to find the torque. So we know that torque is equal to tau, which is equal to F of h, which is the horizontal force, multiplied by R, which is going to be 61.1 newtons, because we have F sub h right there. And then we're going to go ahead and multiply that by the radius, which is 1.22, which is given to us. And then that gives us the torque is equal to 74.542 newton meters. We're going to box that and hold on to that for now. And then the next thing we need to do is find the angular acceleration, which is alpha is equal to tau over inertia, which is I. And that's going to be, if we sub in torque that we found right there, that's going to be 74.542, all divided by 65.2314, which is what we found right there. 2314. And then the angular acceleration, that then gives us 1.1427 radians per second squared. Hold on to that number for now. And then next thing we need to do, the final thing, is find the angular velocity. And the angular velocity is going to be omega is equal to alpha times by your time, which is given to us up there. So if we sub in, it's going to be 1.1427 multiplied by the time, which is 2.89. And then that'll give us 3.3024 radians per second. And then we're going to go ahead and box that, and we're holding to that for now. Finally, now we're able to find the kinetic energy. And that is kinetic energy is equal to 1/2 I alpha squared. And that should come off your formula chart right here. I think all of these they're either on your formula chart, or you can derive them from your formula chart with simple algebra. And then if we sum in our numbers, it's going to be 1/2 times by the 65 point blah, blah, blah that we found right there. So it's 65.2314. And then all of that multiplied by the angular acceleration that we got right here. So it's going to be 3.3024. And we can't forget to square that. And then all of that should be, kinetic energy should equal to 355.7222395364 joules. Now, obviously, you don't need all of those numbers into Quest. However, I am very skeptical of Quest, and I like to just put in every digit my calculator can give me, and I would just type all of this into. Because at some point, I don't know where, but Quest should eventually stop counting numbers, like somewhere here, I think. I don't really know. But that's the answer you get, and that's the math for it.